So, welcome to Chapter 5, Identifying Good Measurement. At this point, you're probably thinking, wow, more on measurement, but as if we're obsessed with it or something. That's not too strong a statement. Without good measurement, there's nothing else you do in a study that you can really trust much. If you haven't measured things well, why bother with any of the rest of it? No matter what connections you show, it's not between what you thought you were showing connections between. So it's vital that you have good measurement. Our goals for this chapter are to get an understanding of measurement quality and how that has an effect upon construct validity. And we also want to understand how we know we have good operationalization, that is, what is this thing called good construct validity? To remind ourselves of what construct validity is, we want to remember that it means that it's the degree to which an operationalization is a good representation of the concept under examination. That is, we've come up with a way of measuring it, we've come up with an operationalization. Is it a good representation of this concept, this idea that's embedded in a theory that we're studying? It all gets back to theories. We'll learn about the various components of construct validity as we proceed, because it's not just a single thing, there's several pieces to it. Now, to get into this, we have to realize that there's more than one way of measuring things. There's several ways to slice and dice the concept of measuring, and one of them is based upon how you get a hold of the data. Self-report is a common way of getting a hold of data from people, simply asking them questions in some way or form. You can ask them a direct question, are you narcissistic? To which you're going to have a difficult time trusting the answers because people don't really know what it means and people aren't willing to admit to their narcissism very well. Mostly because they don't know what it means. Or you can ask them questions you know are related to narcissism, and those are all self-report answers, and use that to build a case for this person has a relatively higher or moderate or lower level of this thing we're calling narcissism. Observational, that's when participants are observed and their behaviors are recorded by counting the number of times they do things or classifications of what we see them do or how we see them make choices and that kind of thing. And in so doing, come up with a measure of that person based on our observations. Another way of measuring measuring variables is physiological. It's when we measure the physical characteristics. Either there's traits or states the person's involved in, traits such as height, weight, personality dimensions. These kinds of things are all, our personality would typically not be measured physiologically, but those kinds of things might be traits or states, things that might change in a moment-by-moment basis. Breathing rate, blood pressure, those kinds of things all change moment by moment. And the thing about physiological measurements they're terribly seductive. We tend to think that they're very meaningful. After all, it's the physical body and we've measured it. But they still rely on validation. Is this thing we've measured in the body actually related to a concept that we're interested in? We're not really necessarily measuring love. We're not really measuring a person's emotional states. What we're probably measuring more of is physiological arousal in general, and you have to have a cognitive component to really get at the emotional state that you believe you're measuring. So besides the fact of the source of the data, whether it be from the person's self-report, from observations, or from physiological measurements, there's also various different scales upon which we can do our measuring. Scores or classifications of the data are how we can one way of differentiating things. That is, we can have some kind of amount or quantity, a quantitative measure, or a categorical measure. When we simply assign people to being, or in one situation or another, assign their behavior to be of a type or another type, assign the observation we make of being of this characteristic or another characteristic. That is a sedan type of car that person is driving. That is an SUV type of car that person is driving. All of those would be categorical measures, as opposed to that person's going 45 miles an hour, that one's going 35 miles an hour, which would be a score or an actual measure. So categorical is simply that, noting a characteristic, and it usually is not numerical, though it certainly could be. For instance, the numbers on the back of jerseys for sports, for athletes in contests, those numbers, they may be related to positions on the field at a certain level, but they're not really related to anything about the player's capabilities, benefits, whether they're the best player or worst player or anything like that. The number is really just a number. It's just a category they've been assigned to. Nominal variables, they don't have the characteristic of higher, lower, earlier, later, stronger, weaker, or anything like that that might somehow classify one relative to another beyond the simple description of different. And so when we say categorical variables, we also might use the term nominal variables, and those terms are virtually interchangeable. Other scales of measurement, though, tend to take on a greater degree of information capacity, and therefore enable us to make more detailed mathematical operations and a greater degree of sophistication in our understanding of what we've observed in a person. A greater amount of information is contained in the measure. These other scales are ordinal, interval, and ratio scales, and we're going to go through each of these individually. An ordinal scale, it simply means that we can characterize observations as being greater, lesser, earlier, later, stronger, weaker, more, less, etc. We can make some kind of characteristic that one thing is higher, lower, etc. than another thing. So, for instance, we can characterize a number of places of difference between two observations, but we really can't characterize the relative distance meaningfully. For instance, we have, say, 10 people who ran a race, and we know that the difference between first place and fifth place is 4 places, right? And the difference between fifth place and ninth place is also 4 places. But what we don't really know is whether or not the person who came in ninth place was very, very close to the fifth place person. There just happened to have been a 6th, 7th, and 8th place person between them, or if they were very, very far away, and how that might compare to the distance between the first place person and the fifth place person. Another ordinal measure that's very common is freshman, sophomore, junior, and senior. And I actually used this in class the other day, as you may remember. But sure, we know what these things mean, but they also are tied to a numerical score. And that numerical score might mean that a sophomore has like 46 credits, and actually it would be like 32 credits, and the freshman might have 29 credits, and we would treat them as being at the same, or being different. One's the freshman, one's the sophomore, but I mean, they're not that different in number of credits. There's like 1 course difference between the two. Are they really that different in terms of their college experience? And so sometimes an ordinal scale, you can see, gives you less information than maybe the information underlying it that builds it up. An interval scale is one where differences between values have a same magnitude. They have meaning, but no matter where along the scale you are, that meaning is going to stay the same. But you don't have a 0 on the scale, at least one that means literally the lack of the quantity being measured. It's an arbitrary point. One of our most common ordinal scales, of course, is our temperature scales. 0 degrees Fahrenheit is cold, but it's not the absence of any heat in the air, or whatever other substance you might be measuring. It's just cold. There are negative numbers on the scale, and you go farther and farther down until you get to a true absolute 0, in which case you shift. So temperature, as we typically measure it on a Fahrenheit scale, is an interval scale, but there is an absolute ratio scales we'll learn about later, where 0 literally means the lack of heat in the air. Most constructs in psychology, those that are self-reports, scales with multiple items about a phenomenon and so forth, are interval scales. There's no true 0. When we have to recognize that we almost never can know for sure that there's a 0 amount of a lot of psychological quantities that we deal with. I mean, what could it mean to talk about someone having a 0 anxiety? Do we literally mean they have no anxiety? Is that even a meaningful concept to have? Can someone ever be completely anxiety-free? We know that we feel more and less anxious in any given moment, and being at our lowest levels of anxiety is, well, It's a pleasant feeling. It's not bad, but could you have even less? It's hard to know, and knowing that it's absolute seems kind of irrational. Ratio scales, on the other hand, do have an absolute zero. Similar to the interval scale, equal distances mean equal amounts of what's being measured. For instance, the difference between 20 points on the scale and 50 points on the scale being 30 points is the same as the difference between 50 points and 80 points being 30 points. That is to say, those distances mean the same amount of difference between the 2 points, even though they're along different areas of the scale. But zero does mean the lack of that you're measuring. None of it is there. You're out of it. So, someone standing still, obviously, they have a speed of zero. That's a meaningful ratio scale measure. A family with no children would legitimately have a score of zero for number of children. Ratio scales allow us to do some important mathematical operations. We can state that when you have a value that's twice another value, it literally means twice as much of it is there. If I have a person who scored 50 on an anxiety scale and another one that scored 25, it would not be rational to say that the person that scored 50 is twice as anxious, because there's no true zero. But if I have someone who is going 50 miles an hour versus 25 miles an hour, well, that person going 50 miles an hour is going twice as fast. $100 is twice as much as $50, and finishing a race in 1 minute is half as fast as finishing it in 30 seconds. You can form meaningful ratios of the measured values, and it's the reason it's called a ratio scale. Now, we have our ways of measuring things, but just because we know how we've measured them, we've not yet gotten to the point of having an understanding of validity. To get there, we have to talk about a couple of concepts. The validity concept itself we're going to get to in a few moments. We have to first talk about another concept that's important called reliability. To have a valid scale, you first have to have a reliable scale. It is necessary for validity. Reliability is an indication of the consistency of the measuring system. Does it yield the same score in situations in which it should yield the same score? If I step on a scale twice within a few seconds of each other, I should get the same number on the scale, if the scale is reliable. We all know that if you step on a scale once and then step on it again, there's actually a good chance it'll yield a different number. But is it a dramatically different number? If I step on the scale once and I get 253 pounds, and I step on it again and I get 240 pounds, that doesn't sound very reliable. If, however, on the second time I step on it I get 252.5, well, yeah, I mean, there's some error there, but it's basically telling me a very similar story about myself, isn't it? It's reasonably reliable. Which brings up an important point. Reliability is not absolute. It is a degree of reliability. So reliability is essential for validity, but it does not guarantee validity. A scale might measure me at 100 pounds every time I stand on it. It would be very reliable in that case, but it's not very valid, because I definitely don't weigh 100 pounds. There are several types of reliability. One that fits what we were just talking about is test-retest reliability. That is, measuring once and then later should yield the same score unless there's been an actual change in what's being measured. So if I'm measuring a characteristic that I don't think changes very much in a person, especially over short time spans, like narcissism, a variable that I do talk about a lot because I studied it a lot in my early psychology career. If I measure a person on narcissism today and then I measure them on narcissism again next week, I would expect to get very similar, if not identical, scores if I have a reliable scale. If I get very different scores in the two measures, one of two things are going on. I either don't have a reliable scale, or the scale is actually not measuring a trait of the person, but is measuring a state of the person. A trait is something we don't expect to change much over time. A state is something we expect to change relatively fast over time. That if I'm measuring narcissism, and if it could change this fast, it would, I would have a narcissism level that's high right now, and an hour from now it could be quite low. And the scale we would hope would be sensitive to that if it's a good scale. But If we're talking about something that's relatively constant over time, we would expect test-retest reliability to be high, that we would see similar scores over time. Inter-rater reliability is when we're observing a behavior, the two different observers will give the same measure, the same score. If we have two observers of how aggressive children are being in the playground during recess, and at the end of recess they all give a score based upon what they observed in 10 children, we would hope that those scores are identical or at least very similar to each other between the two observers. We would hope that if a score of 5 was given to Sally by one observer, that a score of 5 or maybe 4 or 6 was given by the second observer, and then maybe the second observer or observed Jimmy and gave Jimmy a 6 rating, and maybe the first observer we would hope would give a 6, but certainly would not be down there around 3 or 2, but would give a measure of around 5, maybe 7. And so that consistency between the two observers is very important to be able to trust that a scale that you've come up with for measuring something is reliable. And this is referred to as inter-rater reliability because you have two or more raters that you're assessing are giving you the same answers. Internal reliability is kind of a complex concept in a way. If you have multiple observations or items on a scale which are measuring with internal reliabilities, the extent to which they all contribute together to a total score, to generate this total score. Are they all pulling in the same direction or pulling in a helpful way with each other? We expect to see, therefore, high correlations amongst the many items on the scale. That the first question that's asked and the 5th question and the 9th question and the 80th question, if you have that many, all are correlated well with each other and therefore helping the scale to get a sharper, more refined measure ultimately of the construct that's being measured. We have a calculation procedure for this to get at this reliability, and it's called Cronbach's alpha. And effectively what it is an averaging of the correlations from item to item across all the items in the scale. Now, if you've got 5 items on the scale, then you're going to have 5 times 4, 20. You're going to have 10 different correlations, and it's more or less the average of those correlations. A little more complicated than that, but that captures the notion pretty well. A good internal reliability is one that's a high number, and high numbers in this case are numbers that get close to the value of 1 being a perfect correlation. And poor Cronbach's alpha is going to be one that gets close to 0. Numbers that are close to 0, like 0.02 or something like that, it's a really terrible Cronbach's alpha. 0.7 and above is when we start feeling like we've got a pretty good one going. Now I want to give us a little bit of an overview of what's going on with this reliability and validity concept, how they all tie together. So we're after construct validity here, how well we're measuring our construct with our measurement system. Now, one of the things that's important, as we were just talking about, is reliability. Necessary but not sufficient. And the 3 ways we were just talking about for measuring reliability. Now we're going to start getting into validity issues, and I'm going to overview with them a little bit here, and then we'll get into some details about them. There's 2 subjective ways to assess validity. That is to say, 2 ways we assess it without getting into statistical tools and such. One of them is face validity. Does it look like what you think it should be as a measure? And content validity is, are you kind of covering all the bases? Are you getting is your measure capturing all elements of the theory or the concept that are there and not just the favored ones you want or the easiest ones you want to get at? There are also 3 empirical ways to assess validity. That's where we're going to make some measurements and we're going to try to do some statistical analysis to determine what we have. One of them is criterion validity. Is my measure correlated with some kind of observable specific outcome? Convergent validity. Is it associated with other measures that we think it should be associated with? And discriminant validity. Is the measure we have associated strongly, not associated strongly with other constructs, things that it's not associated with, we would not expect it to be associated with? Let's go through all of these and see a little more detail about them. Face and content validity are both judgments that we make. They're about, do they look right? Subjective assessments of the character of them. And you have to have expert knowledge of the construct. You have to really understand what you're trying to measure in some detail. And what you're doing with face validity is just judging. Is it a reasonable operationalization of the construct? If you're interested in how busy people might be, you could say, well, what I'm going to do is I'm going to take a photograph of their desk and I'm going to count the number of pieces of paper I see on their desk. Is that face valid? Does it seem to make sense? And the answer to that probably would be, well, yeah, that sounds like a pretty good way to get at least office workers' busyness. So from a face validity perspective, it's pretty good. Content validity is another judgment that's related to it and similarly subjective. Is the measure covering all of the ways we might think of the concept we're after? So if we're measuring people's busyness, simply taking a picture of their desk sounds like it's not necessarily going to get at all the ways a person can be busy. It doesn't capture the meetings they're going to. It doesn't capture the amount of physical work they're doing in another space. It's only really looking at their desk, which may or may not be representing accurately all of that other work. And so it may be that you're missing out on some other contributors to the concept of busyness by simply working with your measure based upon a photograph on the desk that yields the number of pieces of paper that are in evidence there. Empirical assessments of validity are ones that are going to be using statistical tools generally. Criterion validity is a measure, taking our measure and comparing it to concrete and unambiguous observations. We are expecting to see a high relationship with it. So things that are unambiguous, that you just can't make a mistake in your observation about. Was the person hired for the job or not? Did a person die or not? Did they graduate or not? Was there is a woman pregnant or not? Is a person incarcerated or not? We can go down the line on things that are, there's just not a whole lot of doubt about what you're looking at. No, there's going to be no disagreement generally. Convergent and discriminant validity are effectively two sides of the same coin, and we'll get into some details about them right now. Convergent validity is about comparing the measure with other measures of the same concept or related concepts with an expectation of getting a high correlation. We want to see a high correlation. Now, this can be a high positive correlation or a high negative correlation depending upon which direction the other measures are going. So it's not about positivity and negativity, it's about magnitude. And correlation, since they can only go up to a maximum of 1 and their minimum score is 0, a maximum of positive 1 or a maximum of negative 1, and 0 being the negative magnitude you can get. What you're wanting to see is either numbers relatively close to positive 1 or relatively close to negative 1 for good evidence of convergent validity. Discriminant validity, sometimes referred to as divergent validity, is about comparing the measure with other measures that are not related, that you don't expect to see high correlations with. And so they're going to get correlations that are 0.12, 0.06, 0.0, those kind of correlations that leave you like going, well, there's no relationship there. And that's good news. You don't want your measure to be capturing something about some other measure. You want it to really kind of stand alone and only be measuring what you were after in your construct. So let's do a little bit of imagining here. Let's suppose we've come up with a new measure of depression that relies only on pictures for people to give feedback rather than answering questions, and it has and high scores on it mean more depression for the client. We're going to call this the Frostberg Iconic Depression Scale, or the FIDS scale. Now, to satisfy convergent validity, we would expect this scale to correlate highly with other measures of depression, sadness, maybe anxiety, and we would expect it to correlate negatively and highly with measures of happiness, well-being, and so forth, right? We would expect both of these things to be true if we have good evidence of convergent validity. To satisfy discriminant validity, we would expect it to have a low to zero correlation with constructs that are not related to depression, such as intelligence, trustworthiness, timeliness, and so forth. So let's imagine these are correlations, that we have our FIDS scale. We took the same exact people and we measured them with our new FIDS scale with Beck's Depression Inventory, which is a real standard and well-validated depression scale, Diener's Happiness Scale, which your book talks about a little bit and is a good, well-validated measurement of how happy people are, an IQ scale, which regardless of a lot of validity issues with, we tend to get good reliability with, if nothing else, we think is measuring general cognitive capability, and trustworthiness, a scale on trustworthiness of a person. We would expect certain patterns to emerge here, and I want you to look at this for a few moments and think about, what do you think this pattern of correlations tells us? Keep in mind that correlations to get towards 1, negative or positive, are good, and those that are relatively close to 0 are bad, and 1's the most you can have. So let me get into it a little bit here, now that you've had a chance to think about what you think this pattern might be telling us. 0.85 positive is a high positive correlation, and that's good for evidence of convergent validity. Similarly, Diener's Happiness Scale is a high negative correlation, and that also is consistent with convergent validity. That is, we have two convergent validity indicators that are what we would want them to be if our FIDS scale is also a good scale. And we see IQ, and we see and trustworthiness, and we see both of those are low correlations. That is also good. These low correlations are what we would expect to see if we have good discriminant validity. That is to say, we don't want to see high correlations with our FIDS scale with IQ and trustworthiness. In fact, if we were to get, say, a high correlation for trustworthiness, we would worry that our FIDS scale, while it might be measuring depression well, is also capturing something about trustworthiness, and that might be tainting our findings, that we might be measuring more than just depression, which is really not good for us to do good research work. So in closing, we must be assured that our measures are valid. This is core to being able to do any of the work that we do in research. If we haven't measured well, nothing else really matters. So our construct validity of our operationalizations needs to be good. We know that some reliability and validity assessments therefore need to be done. And what we're doing is trying to support construct validity, the overall notion of how valid is our measures, by these analyses of reliability and individual points of validity towards construct validity. It's also very important to recognize that none of this is absolute. We don't come to a point and say we have validity. What we have is support for validity. We have evidence that the validity is good or is sufficient. We never have absolute knowledge of validity. It is a bit of a sliding scale. It's somewhat based upon the state of the art in an area of research. If the best anyone's ever been able to come up with for a valid scale is only okay, well, then you have to live with the fact that you're going to have a lot of extra error in your measurements, and it may suggest you've got to do bigger studies, or maybe you need to work in a different direction or on some different problems, because the state of the art is not sufficient for us to really measure well in this area yet. So we're always working to improve our measurement systems, whatever it is we're doing, because it is foundational to being successful in any area of research. That's it for today. Chapter 6 is next, but that'll be after the next exam. Thank you. Bye.